Okay, now this is the high level synthesis or the HLS phase of the project. Now the high level synthesis and HLS phase of the project is the first phase of the project, because the accelerator is first written in a high level language, for example C++, and it is compiled into the hardware by using the Vivado HLS process. So over here we have got this FPGA top, which is the main module for the accelerator. Now we have the accelerator which is connected to the DRAM, but basically for fast operation we need cache memory in the fast block RAM available on the FPGA itself. So that fast block RAM is used to create cache memory for our accelerator, and we have different kinds of cache. Global pool cache holds the result of the global pooling of the weights. Image cache memory contains the input image of the accelerator. The output cache holds the partial output results of the process, and from later on we sum up to obtain the output from the process. Then we have the weights cache, which is again a local fast VRAM memory that holds all the weights of the accelerator. The weights for a particular layer are handled in this particular weights cache. Then of course we have the processing elements, and the processing elements basically are kernels that operate on 3 by 3 multiplications and additions, and we have a number of these processing elements that are working together. Okay, now we have this particular definition of our top module, and basically we have different types of variables are there and different type of interfaces are there. We have got this slave accelerator ports, which are variables to the accelerator, and this is basically shared DRAM port. It is basically a master EXA interface, and master EXA interface has very fast access to main memory. Now we have the setup things, which is setting up the memory controller, and memory controller is set up by providing it the address of the shared DRAM, the address of the weights offset, and the address of the inputs offset. Weight offset is the location from where in memory the weights are stored, and input offset is the location where the input is being stored. Then of course we set up the layers, and we call the set layer config function for image cache, weights cache, set layer configuration, and as well as memory controller and processing element, because we are working on the number of layers. So we specify how many layers are there. Then of course we load the weights from the DRAM, and by using this function of the weights cache, which is load from DRAM. Then again we use these member functions to set up the pixels for the memory controller, image cache, memory controller again, and the image cache. So we are basically preloading from the DRAM. Again we are providing the address of the shared memory, and we have provided the addresses of different input offsets and weights offsets, so it can calculate the respective addresses. This is the main convolution loop which occurs for the entire height and width of the current layer, and basically we execute it by using the accelerator. Then we can preload pixels from DRAM into this image cache, and after basically we are done, we do it for all input channels by looping through these input channels, and we process a particular input channel by using the YX input channels, right, output channels parameters so that the inputs can be processed, and we have this different output pixel coordinates calculation functions that can work over here and provide us the answer. Then of course we can post process the message by using this particular loop for output each number of output layers or output channels to finally accumulate a particular channel into the global pool cache, but only if the current layer is a global pooling layer. Then we can write back the final result from by using the write back result member function of the memory controller. Again, shared DRAM is the variable that is called or used for it. And of course, if synthesis is not defined, we are just simulating the code. We can have different types of diagnostic functions by writing the DRAM image data to the file by which we have checked the output of the algorithm, and these functions are all coming over here. So we can use this thing to find or troubleshoot the results. So this is as far as the function is concerned. Of course, we can run the C simulation and we can run C synthesis, and after that we have got these particular results for the synthesis of our solution, in which we have got the clock timing, right, which is estimated to be 8.75 nanoseconds, and basically the latency and the interval calculations. Also we have this resource utilization of our design. This resource utilization can be seen, and of course this is the interface summary, how the signals have been generated for each of these particular variables and interfaces of our module, RTL module. So this is as far as the overview of the high level synthesis flow is concerned.